Hello everyone, so now we are going to discuss the OSPF metric. If you remember, each routing protocol is having different metrics. Like before we discussed, RIP is having the hop count and OSPF is having the metric as a cause, and we told EIGRP is having the bandwidth and delay. We did not cover the EIGRP. After we finish OSPF, we are going to look the EIGRP also. So now we need to check. We are saying OSPF metric is cause. So we need to remember cos is equal to reference bandwidth divided by interface bandwidth. This is a formula given by Cisco, and what we can say, first thing we need to remember, OSPF metric is cos, and cos is equal to reference bandwidth divided by interface bandwidth. This point we need to remember. In interview they will ask you what is the OSPF metric, so we need to say cos, and they will ask what is cos. Cos is equal to reference bandwidth divided by interface bandwidth. For which interface you want to calculate the bandwidth, that interface bandwidth what we have, we will divide that one. And reference bandwidth is nothing but 100 Mbps in the Cisco router. So this point also we need to remember. In the Cisco router, default value for the reference bandwidth is 100 Mbps, 100 megabyte, that is nothing but 10 to power of 8. Okay, so what we can say, OSPF use metric called cos, which is based upon the bandwidth of the interface, and we can calculate this by using the formula cos is equal to reference bandwidth by interface bandwidth, and reference bandwidth is a default value on the Cisco router, that is 100 megabyte, and it is nothing but 10 to power of 8, and we can divide that 10 to power of 8 with the reference 10 to power of 8 with the interface bandwidth to get that value. And the lower the cost, the better the path. As we discussed, whenever we have the low metric, we will prefer that path. And the router which is having the low cost, that value is going to prefer, and that is going to store in the routing table. If you have the two path with the equal cost, then OSPF is going to do the load balancing. Example, if you have like this scenario, if you want to go from here, example R1 to R2, you want to go to R1 to R2. You have two paths, one is this one is this one. Both are having same cost. Example, this one is also having one cost, this one also having one cost. This is a fast Ethernet 0 by 0, this is a fast Ethernet 0 by 1. This is also 0 by 0, and this is a fast Ethernet 0 by 1. So what OSPF will give, if we have the equal cost, both the link, then he will send one packet from here, one packet from here. They will do the load balancing. OSPF will do the equal cost load balancing. Equal cost load balancing. Equal cost load balancing means we will have the same cost. If you have 1 here, here should be 1. If you have 10 here, here should be 10. But you need to remember, EIGRP is doing equal as well as unequal. Unequal and equal. So even if you have the unequal cost or equal cost, they will do the load balancing in the EIGRP. But in OSPF, they will do only for the equal cost. We need to remember this one. Okay. So now what we are saying, if two path is equal cost, then OSPF is going to use the both path. They will do the load balancing among them 50%. 50% traffic will go up, 15% traffic will go from the below. So this one we understand the formula. Now we have the idea, and we need to remember this box. This box is very simple. Ethernet link. Okay, Ethernet link, we have fast Ethernet link, we have serial link, we have gigabyte link, we have 10 gigabyte, 40 gigabyte, 100 gigabyte. So this is a default value of the interface. If we are using Ethernet, then we will have the 10 megabyte. If we are using the fast Ethernet, we will have the 100 megabyte. If we are using the serial, then we will have 1544 kbps. If we are using the gigabyte link, then we have 1 gbps. If we are using 10 gigabyte link, then we have the 10 gbps speed of the bandwidth. This value we need to remember, so we can easily calculate. If we did not remember, we can get this value also, no need to worry. If we go inside the router and we check the interface, we can get this value also. I will show you how we can get that value. Now just we need to remember, 1 megabyte is nothing but 10 to power of 6. Okay, 1 megabyte is nothing but 10 to power of 6. Now what I will do, I will go any interface, I will go in the R1. Okay, in R1 I will check the interface bandwidth. What is the interface bandwidth in the R1? I want to verify that one. So what I will do, I will write show interface fast Ethernet 0 by 0. Okay, I wrote show interface fast Ethernet 0 by 0. So if you see, this is the bandwidth. Okay, this is the bandwidth. What is the bandwidth is written here? Here bandwidth is nothing but BW is equal to 1, 2, 3, 4, 5. Okay, 10 to power of 5. And if you see kilobyte, if I want to remove kilobyte, that will be 10 to power of 3. So total will be 10 to power of 8. 5, 6, 7, 8. So bandwidth for the fast Ethernet is how much? 10 to power of 8. 10 to power of 8 is nothing but 10 to power 100 megabyte also we can write 100. Let me show you here in our notes what we wrote. This one 100 megabytes. If you see here, 10 to power of 6 is nothing but 1 megabyte. 10 to power of 6 is 1 megabyte. So what value we have here in the router? Just now what we observe, we have 10 to power of 5 and we have 10 to power of 3. So we told we have 10 to power of 8. This value just now we check. How we check? We have 50, 1, 2, 3, 4, 5 and kbps. So if I want to remove kbps, I need to add more 30. So if I add 30, 1, 2, 3, 4, 5, 6, 7, 8. So 10 to power of 8. This value is the, what is this value? This value is for fast Ethernet 0 by 0. Okay, fast Ethernet 0 by 0. That is nothing but this one. If I want to remove, if I want to convert this into 10 to power of 0, how I can convert? I will write 100 megabytes per second. I want to remove the megabytes per second. So I will write 100. When I want to remove this one, I need to write 10 to power of 6. So I will write into 10 to power of 6. So 6 and this 2. So 10 to power of 2 into 10 to power of 6. So what is this value? 10 to power of 8. That means this is a 10 to power of 8. This is nothing but 10 to power of 8. And if you see, just now we check this one also 10 to power of 8. So just we are comparing. We are saying that this value we need to remember. If we did not remember, we can log into the router and we can check the interface and we know that 10 to 100 megabytes. That is nothing but 10 to power of 8. Okay, this value just I shown you, but if you remember directly, no need to check and do calculation. Now you know what is the formula? Cos. Cos is equal to reference bandwidth. Reference bandwidth always Cisco told 10 to power of 8. We write 10 to power of 8. Divide by interface band. Whatever interface you want to calculate the cost, that interface bandwidth we need to write here. So this interface, example, this interface. So this is a 100 megabytes. 100 megabytes we told we can write as a 10 to power of 8, right? Just now we do calculation. So I will write 10 to power of 8. This one cancel. So you will have 1. So cos will be 1. So this is a 1. Okay, this is a 1. Now we will do for the Ethernet link. We will do for the Ethernet link. Ethernet link is having 10 Mbps. So C is equal to 10 megabytes, this value. Or let me take both. What we are saying, cos. Cos is equal to reference bandwidth divided by interface bandwidth. Interface bandwidth. And C is equal to, we can say 10 to power of 8. Okay, and the interface bandwidth is 10 to power of 7. So when we calculate, we have 10. So cos will be 10. If you are confused, we can write this way also. This is 100 megabytes per second. And this one is a 10 megabytes per second. So this cancels. So you have only 10. So 10 will be the cost for Ethernet link. Okay, let me show you here. This one I am saying. This one 10 megabytes. Reference is nothing but 10 to power of 8. 10 to power of 8 also we can write like 100 Mbps. This one also, this one both are same. So I divide this value with the 10 Mbps. So we have only 10 here. So this is a cost for the Ethernet link. Same thing we can do for this one, but easy, just remember Ethernet is having cost in the OSPF. In OSPF, Ethernet link is having the cost 10. fast Ethernet is having the 1 and the serial is having 64. All other above interface above the, means more than fast Ethernet means giga, 10 giga, 40 giga, all are having 1. So just remember serial 64, Ethernet 10 and all other will have 1. If you remember also, that's okay. In interview if they ask, you can calculate or you can just tell that cos is equal to reference bandwidth by interface bandwidth. Reference is nothing but 10 to power of 8. Interface means this value. Or we can check in the router. Just now what we check this one. K means 30 kilobyte, kilo 10 to power of 3. So this is 5 and 3. That means 10 to power of 8. So now we will do one lab, so we can verify that one also. Okay, we will do one lab, so we will have that idea. This is a theory, and now we will do the lab. In that scenario, we will take one router or 3 router we will use. So let me stop this recording.